Okay. Hello, everybody. I'm Alessandro Rudi. I'm going to present GURLS, that is the library we developed at LCSL. It stands for Grand Unified Regularized Least Squares. Okay, as you have seen during the course, machine learning is made up of three important ingredients that are a number of examples, a preprocessing step where you obtain your data representation, and then a statistical modeling step. Here we focus on the statistical modeling. So we have to do many choices. For example, which algorithm should we choose? And when we have the algorithm, how to select the hyperparameters range, and how to select the right value of the hyperparameters in that range. So the machine learner life is kind of recycling parts of code that you know that they works with the risk to have subtle bugs that replicates in your code. So the idea of our library is to automatize all the choices. So to have a completely automatic library for machine learning. It is targeted to multiple users, from the casual user to the expert machine learner. So for people that probably don't know anything about machine learning, but just have a learning problem and they want to press a button, to people that probably have their specific kernel, but they just want to use, for example, to reuse code for parameter selection. So, for the causal user, GURLS is as simple as writing GURLS train and GURLS test. So the library analyze the data and understand if the problem is of regression, of classification, then selects a suitable algorithm, suitable ranges for the parameters, and then optimize it. If you are an advanced user, so you know what a kernel is and probably a good range for your parameter, you have just to specify it in the function. So, for example, here, we perform the learning with a Gaussian kernel with sigma 0.1. In general, if you have more knowledge about your problem, you can just specify it in the GURLS train function by a sequence of parameters and values. The parameters range from algorithms, kernels, model selection, parameters. So you can choose between a lot of variants of kernel regularized least squares, kernel logistic regression, Gaussian processes, random features. You can choose a lot of kernels, and the most important model selection techniques that are well tuned for the given algorithm and kernels. Now we give just some examples. So we want to learn, this is a regression problem, we want to learn a function that estimates this data set. In the first case, we want to learn a linear model. In the other case, we want to use kernel regularized least squares with the Gaussian kernel and the Weber filter. Filters are computational ways to obtain the estimator. So this is what you obtain, and you can obtain it by just typing GURLS train and specifying that you want as algorithm linear regularized least squares or algorithm kernel regularized least squares with Gaussian kernel, and as filter you use Landweber. So it is for advanced user. If you are a more expert user, probably you want to go under the hood of the library and use specific parts of it. So you have to know that GURLS is organized in a pipeline where each computational step is a block of this pipeline. In this way, the structure is highly modular, and you can just reuse part of the library of the pipeline and changing only the part where you have, for example, new code for. So for the example we have seen, for the linear case, GURLS train produces this pipeline made of 3 blocks. So the first block computes, splits the dataset in a training and a validation part. The second block computes the optimal lambda, and the third block estimates the linear function. In the other case, the other example we have seen, GURLS train with such parameters produces a pipeline with 4 steps. As before, we have a splitting phase, a parameter selection phase. Here we have a phase where we compute the Gaussian kernel, and then we compute the GURLS solution by using the Lamb-Weber filter. So an expert user can just modify the pipeline with his own code, for example, and reuse, just to say, the splitting part, the model selection part. It is possible because each block in the pipeline is a function, and such functions have the same signature. So that is given by the stage name, so split parameter selection, for example, and then the function name, while the arguments are just the same. Here we have some examples. So here we have the signature for the kernel RBF, for performance measures, for linear RLS. Okay, when we developed the library, we didn't take into account only the user experience, but we focused on the performances. In fact, here, for example, we have a graph where we see on the y-axis the performances with respect to the time, and we compare GURLS as casual user, so when you type GURLS train, with respect to a state-of-the-art machine learning library that is libsvm. And we compare them on here we have 5 very famous data sets. As you can see, the GURLS is given by blue points, while libsvm are these 5 points. We obtain better performances by spending a bit more time. But if we select other filters, we obtain the same performances as before, but by using absolutely less time. So it means that by having a library that gives you the possibility to change the learning algorithms and some learning options, you can select the point that you like in the performances time trade-off. So if you want a very accurate solution, you can select the associated parameters. Otherwise, you can opt for solutions that are faster but probably less accurate. There are not the slides on the model selection times. Okay, we can just use this table. Another important point on which we spent a lot of time developing the library is the model selection time. It is important because if you see the advertisement of the other libraries, they see, oh, it is very, very fast and precise, but they don't tell you that it is on the training and test time, while when you are learning, you have a model selection time. So how much time do you need to select the right model for your learning algorithm? Here you see, for example, that using GURLS, PubFig, it is a data set of face recognition. It is quite famous in the field. And by using GURLS, you obtain the accuracy of 87% in 13 minutes of model selection, while IBVM obtains 76% of accuracy in 5 hours. So the idea is that the model selection step is crucial when you are learning, and so we spent a lot of time in optimizing it. So it is a key feature of this library. Here you see a real-world application where GURLS is used for real-time stereo vision and object recognition in ICAB. And the whole system is consistently faster, as you can see for the table, and more accurate than the competitors. So it is used in practice. It is an important point. So you can download it from the GitHub site, or if you are more curious, you can just read the paper associated to it. Just to say, at 2 p.m. we have a tutorial, a lab. It is kind of an hour, I think. And so it is optional. If you like, you're welcome. Then there is, we prepared just for fun a challenge. So just to see what you have learned, how skilled are you in machine learning. Okay, I finished. Quindi sarà, facciamo un